Hi, my name is Abhinav, and this is Adam, and we're going to teach you how to graph quadratics in standard form. Things to know before we start to teach you is how to identify a domain and range of a quadratic, know what a leading coefficient is, and how to factor when a is 1 and when a isn't 1.
Okay, so to begin with, we're going to go right into an example. So we're going to be using the equation x squared plus 4x plus 4. And so the nice thing about quadratic functions in standard form is that you can immediately identify the y-intercept. The constant over here is the y value over y-intercept. So let's write that down. Okay, and so now we can also obtain the vertex of this function by using the formula negative b over 2a, which is a very important formula to know. So in this case, our b value is 4, so we'll do negative 4 over 2 times 1, because in this case, our a value is equivalent to 1. So that will result in a value of negative 2. So now we have the x value of our vertex at negative 2. And so to get the corresponding y value, we can simply plug in negative 2 back into the equation. So we see here negative 2 squared plus 4 times negative 2 plus 4. And right off the bat, I can tell that this is equivalent to 0. So our y value for our vertex is 0. Therefore, our vertex is located at negative 2, 0. Let's begin by graphing these 2 points that we already know. So we established that our y-intercept is at 0, 4, because looking at the constant. 1, 2, 3, 4. And we established our vertex was at negative 2, 0, which we can plot like so. Now we need to see if there are any other x-intercepts. We can do this by factoring this. So we can do x squared plus 4x plus 4. Well, I can see that it is a perfect square, and go into x plus 2 squared. And by setting this equal to 0, we can tell that x equals negative 2. And since we already know what that is, which is our vertex, we know that we only have one x-intercept, which is located at our vertex, which is all right. Another thing we can tell is that the x value of our vertex will also be your axis of symmetry. And so what we can see here is that we already have a point on the right side of the axis of symmetry at 0, 4, because that is our y-intercept. But we can also get a free point per se by using this point and seeing what it would look like reflected over the axis of symmetry. Since it is at 0, 4, and the axis of symmetry is located at x equals negative 2, we can see that the corresponding point has to be at negative 4, 4, like so. So they both correspond on either side of the axis of symmetry. And so now it's simply a matter of drawing our lines, like so. And you've successfully graphed a parabola for a very simple function. And if you want any more points, you can simply plug in x values along the x-axis to get the corresponding point and then plot it on your graph. But now my friend over here will go into a more complicated problem.
So straight off the bat, you can see that there's a negative leading coefficient right there. So this tells you that the graph will be facing downwards. And now you look at the value of a. Realize that a does not equal to 1. So you have to factor by grouping. We could take a negative x out of this one. And out of this one, we could take a negative 1. So when we set negative x minus 1 to 0, you get negative 1. And when you set 2x minus 3 to 0, you get 3 over 2, or 1.5. So you could easily graph that. And then to get the vertex, use the formula I said before, negative b over 2a, which gets you a value of 0.25. Then you plug in the 0.25 to x, and you get 3.125. So we know that the vertex is 0.25, comma 3.125. And you can plot that about right there. All it takes now is just drawing the lines in. And you've graphed a quadratic function when a does not equal to 1.